Welcome to this explainer. Today, we're launching a geochemical investigation into, well, one of the most bizarre and genuinely isolated phenomena on Earth. We are opening up a fascinating cold case file. Literally, we're going to track down the truth behind a geological mystery that honestly sounds like it was pulled straight out of a fantasy novel. But, as you'll see, it's very, very real.
When we think of an active volcano, we all kind of know the drill, right? We expect highly destructive outputs, lava, ash, and, frankly, horrifying death. But our investigation today centers on a literal gate to the underworld that marches to the beat of a completely different drum. Because this particular volcano, which just buttles away with a permanent lava lake, isn't just emitting your standard toxic gases and molten rock, it is literally spewing pure elemental gold crystals into the sky. No joke.
Section 1. The Frozen Crime Scene. Antarctica's Hidden Fire.
Okay, so to really understand this anomaly, our investigation first has to take us 1,350 kilometers. That is the exact distance separating Mount Erebus, which is the world's southernmost active volcano, from the geographic South Pole. It's located out on Ross Island in the Ross Sea, basically a deep bay in Antarctica. It just fumes away in incredible isolation. So we're talking about an extreme environment, harboring an incredibly extreme secret.
Moving on to Section 2, Uncovering the Golden Evidence. A 1991 discovery. Let's dive right into the evidence. So, back in a 1991 investigation published in Geophysical Research Letters, a team of researchers decided to probe the emissions of Mount Erebus. And what they found? It completely defied expectations. They collected samples from the snow around the crater, the plume of gas coming off the lava lake, and even just the surrounding air. And in all of them, they found pure elemental gold. But here is the kicker. Under an electron microscope, these weren't just irregular, messy little specks. No, they were intricate, perfectly faceted geometric crystals. Some of them measured up to 60 micromolars across. And the volcano was projecting these microscopic treasures incredibly far, scattering them up to 1,000 kilometers away into the Antarctic troposphere. Which brings us to a pretty staggering figure, 80. Every single day, Mount Erebus belches out about 80 grams, so about 2.8 ounces, of this microscopic gold dust. Day in and day out, this volcano just operates like a natural, relentless gold fountain. Now, before we jump to the conclusion that Erebus is the greatest gold mine on Earth and start packing our bags, consider the competition. Trace gold in volcanic emissions actually isn't all that unusual. Kilauea in Hawaii, that produces an estimated 500 to 800 grams a day. Mount Etna in Italy, up to an estimated 2.4 kilograms, or 2,400 grams. So, chemically speaking, these other volcanoes are pumping out way more trace gold. So, what does this all mean? The crucial point is absolutely not the amount, it's the form. And that is the real mystery we are investigating here. To date, Mount Erebus is the only volcano in the entire world known to spew beautifully formed crystalline elemental gold particles. Sure, Etna and Kilauea have gold mixed up in their chemical soup, but Erebus is out here literally crafting perfect, microscopic, geometric crystals. Section 3. The Impossible Volcanic Escape. How gold leaves magma. So how exactly is this pure gold escaping the magma and making it into the freezing Antarctic air intact? I mean, it's a fundamental question of physics. The boiling point of pure gold is far, far hotter than the blazing temperatures you'd find in volcanic lava. That means the gold isn't just evaporating like, say, water boiling out of a kettle. It can't just magically turn into gas on its own and float away into the sky. It needs help. And that help? It comes from a volcanic melting pot. Deep underground, a volcano is basically a giant hole in the Earth's crust where molten material seethes upward. In this extreme subsurface environment, gold is thrown together with elements like copper, silver, mercury, arsenic, selenium, and sulfur. Because the gold can't just evaporate on its own, it's forced to bond with these other elements to form chemical compounds. It essentially has to hitch a ride on other gases just to make it to the surface. Section 4. Investigating the suspect theories, 2 scientific models. We know the gold has to hitch a ride out, right? But how does it break free from those compounds to form these perfect, pure crystals in the snow? Well, we have 2 very different suspect profiles for how this crime went down. On one hand, we've got the chlorine compound transport model, which suggests the magic all happens up in the air. On the other hand, the lava lake crust model suggests the magic happens right down on the surface of the lava. Let's interrogate both of them. Okay, let's start with the chlorine transport model. This theory proposes that the gold travels out of the magma, safely tucked inside volatile chlorine or sulfur-bearing compounds. Then, as these extremely hot gases exit the lava lake and smack into the freezing Antarctic troposphere, they cool incredibly rapidly. As they cool, the gold separates from the chlorine, crystallizes midair, and then just drifts down to rest on the snow. However, every good investigation has to look for holes in the theory, and the glaring flaw here? It's the chemistry. There is remarkably little actual gold suspended in that gas. Given those incredibly trace amounts, the spontaneous nucleation, meaning the sudden mid-air formation of such intricately beautiful geometric crystals, is just exceptionally difficult to pull off. It doesn't quite add up that perfectly formed crystals are just popping into existence in thin air like that. Actually, to counter this, Philip Kyle, a volcanologist on the original research team, proposed a second scenario, the lava crust model. This theory suggests the gold takes its sweet time. It separates and forms gradually, directly on a crust sitting atop the bubbling lava lake. Down there, it achieves its perfect geometric crystalline shape, and only after it is fully formed do the rising volcanic gases catch these finished crystals and bear them aloft into the massive plume. Section 5. An unsolved geochemical case. The mystery continues. So we have our evidence and we have our theories. But here is the truly fascinating reality. More than 30 years after Kimberly Meeker and her team published their incredible discovery back in 1991, scientists still do not have a concrete answer. And I think this brilliantly illustrates why Mount Erebus captures the scientific imagination so completely. As an article from Science Alert perfectly phrased it, something gives this volcano a unique ability to sprinkle the snow with gold dust like a mischievous pixie. Something about its ambient temperature, or maybe its totally unique geochemical makeup, turns a terrifying, blazing force of nature into just an enchanting mystery. As we close out this case file today, I really want to leave you with this final thought. What missing piece of evidence will it actually take to finally solve the mystery of the Golden Volcano? Is there a geochemist out there ready to brave the brutal Antarctic cold to find out for us? Because until then, Mount Erebus is just going to keep quietly erupting its perfect gold crystals over the frozen ice, waiting for someone to finally uncover its secret. Thanks so much for joining me on this explainer, and remember to keep questioning the world around you.